Oh, all right, we're going live.
Here we go.
All right, hello, folks. Welcome to the second talk of the day. There is a lot of madness involved in K8s, and here to help you control your APIs, rather, I have got Rafael. Rafael, take it away.
Thank you very much. Thank you very much. Let me quickly share my screen here, and off we go. So first of all, hi everyone. I'm Refael. I'm responsible for customer experience in Up9, and I want to talk to you today about Kubernetes and have one piece of the puzzle completed for you, so you'll be able to co-op with troubleshooting in Kubernetes environment. So in the next 45 minutes, what I would like you guys to leave from here is, first of all, have an understanding. I want to create like a baseline. You're new to Kubernetes, or if you're a savvy in Kubernetes, 5 minutes, get everybody online. What is the problem with Kubernetes and developers, and like what is so different about it, and what is the missing part of the puzzle that creates all that friction? I'll introduce you to an open source that we are the maintainers of it, and I'll quickly explain about it, do a quick demo, quick 15 minutes, and really in that place, if you have any questions, feel free to use the Q&A for that, and I'll leave 5 minutes for frequently asked questions, and I also prepared some that probably some of you are going to ask, and a quick slide of how to get that. So let's start. So the first thing is, when you look at Kubernetes, I look at it as a forest of applications. It's not just one application that we used to have. It's now tons of microservices. Every microservice its own realm and abilities, because microservices allows us to decide which protocol we're going to use, how it will scale. It will be synchronous or asynchronous, right? So if I'm an on-call, or I need to create an integration with the team next to me with their microservice, it's basically just like creating an integration to another application. I need to know the APIs. I need to know the menu for that. And if we take a step back for that, like how we started with the monolith a couple of years ago, a single app. We had external APIs. If you call to like Stripe or some external like Salesforce, yeah, we knew that. We used the sandbox. Our code base was basically constructed out of two elements. One, the code that I am going to develop, which is the private functions, and the code that is just one include from me. So a colleague of mine just, oh, for sure, just include that code, and voila, I have everything on my laptop, step by step debugging. Everything works well. With microservices and the introduction of the Kubernetes, all those public interfaces are now exactly as an API external. That means debugging my code now becomes one. I need to think of my code as not something that run on a single machine. It can run on multiple machines at the same time. It can be activated by a call of an API, or by a Kafka message on a bus, something, or even like a serverless application that can call my code. I need to co-op with that. It needs to be synchronous, asynchronous, maybe both. And the problem is that as a developer, I still have just the access to the code. But to debug the code, the full service, I actually have to see the entire code, which means all the application and how they are actually working together. So for that, if we look at the tools that we have in the microservices environment, we of course have the traditional APM and monitoring, which are there, and they give us a lot of good things about like what happens if something breaks, CPU measurement, stack, and everything. We have distributed telemetry, which is great. It allows us to actually kind of say, hey, where is my entry and exit point? And I can look at that. Super good. I can implement it on the code. Great, as long as I control the code. And I thought about that. And then we have production debuggers, such for example as Glytron, right? Which allows me to debug my code, even if it's on like staging environment or even if on production environment. Assuming I know what is the code that I want to do. But what happens if I'm being activated by someone else, or I need to activate code and then see that? The full picture of the API is a little bit missing. And the way people are doing that is uh, shooting everything to logs, or trying to place TCP dumps everywhere and trying to get that, which creates a lot of overhead on the DevOps, because the developers won't necessarily have all the ability to all the permissions to do that in production. And now you need to sustain all those logs and have a centralized place for them, and then slice and dice on them, and then keep them, and then forget to delete them. And this is the reason why we created Mizu. Uh,
Raphael, sorry, just before you get on with the music, do you want to put it full screen so then everyone can see it? Just for those that have got like, bad eyes or small screens.
yes, sure, I can try and do that. 1 second. Slideshow. Okay. Is that better?
Yeah, that's fantastic. Thank you.
Super. Great. So, what Mizu is? Basically, an open source tool, point and shoot. And if I need to summarize it with one sentence, think of Wireshark, centralized or reinvented for Kubernetes, with the look and feel of your Chrome DevTools. Just like if I tell a front-end developer, hey, listen, you don't have DevTools anymore, probably they will tell me, you know what, Rafael, that was nice working with you, I quit. This is how developers, the backend developers feel, because they need to have that ability to see what happened. But the problem is that it needs to be across protocols. It needs to be with TLS and MTLS, outbound connections and inbound connections for that. And they need to see it live, and they need to see it exactly when they need it. So think of like, I'll tell you, hey, if to use the Chrome DevTools, you will need to put like a breakpoint before that. And then, no, you need to see it now. So that's exactly what Mizu is doing. And what I'm going to do in the demo today, don't worry, we'll get to that in a second, is go with you on a couple of use cases. First, how we start. I want to see the traffic now, so we'll understand how we do that. And then, how do I explore like the environment I'm at right now? So what are the services that I want to, where is my service, how it's called? Which services call that service, and what other services I need to interact with? If I have a problem, how do I troubleshoot it? And I show you how to slice and dice with that. Found a problem. Can I do something proactively? Maybe I want to create a rule that if that something happens, is going to give me a Slack alert. Or I want to have like a contract, like my open API spec. I want to make sure that I apply that on the traffic. So if somebody breaks the contract, I want to know about that. I want to sleep good. And if we have time, I promised I'll show you something that is going to be released soon. And since we see the traffic, how can we actually see personal identifiable information on our traffic to make sure we are compliant with things like, let's say, HIPAA, or that we don't move the information to where it's not supposed to go. So with that, let's start. The first thing I want to do is I want to introduce you to this nice cluster, which runs my my WebSock application. And what I would like to do is install Mizu. So the first thing I'll do is go to Get Mizu, pick the operating system. You can do that from the GitHub as well. It's just more visual and nice from here. Copy, paste, and I've just downloaded Mizu. If my internet connection will be a bit faster, great. So I've just downloaded Mizu, and all I need to do is Mizu tap. I can say I want to tap everything, my entire cluster, or I can say I want to tap a specific namespace. In my case, it's Sock Shop. So I'm going to tap just Sock Shop. Press enter, and behind the scene, what just happened, Mizu just spun up a container, which is this beautiful HTTP that you're seeing, and 3 daemon sets, which are now looking at the traffic and transmitting all that traffic to that API server so we can see that. Achievement done. I am now able to literally see my screen, so we can strike that one. How can I understand, like, what is the environment I'm like? Let's say dev versus pre-production versus production. While we see the traffic, we actually show the service map. And again, I didn't have to install or change the code or something for that. If I have Istio or Linkerd, it's automatically configured, and you can just do a -- service -- mesh, and you get that as well. Now I'm able to understand front end calls orders. Orders is interacting with, and we have something here that calls an active queue, which is Rabbit, and I have other protocols. Of course, we can slice and dice with that. And the more important thing, I want to start debugging an issue. So, unfortunately, the WeaveSock guys, I've found some kind of a problem with the login. So I'm going to share it with you right now. If I'm doing a bad login, what? Before I do that, let me show you how I can actually pinpoint, because you see a lot of traffic here, right? So let's just hold it for a second. I want to see only HTTP traffic, and I want to see the response code only if it's going to be an error, which means 400 and above. Okay, click apply, and let's start. So I'm going to do a login. This is a user that does not exist. So I'm going to do a login with that. You can automatically see that, let's stop that. I see the 401 that my browser got, right? So unresolved because it's just an IP to the front end. And I can see the dynamic tracing that was created on the spot. So we have 500 that got, and we can see that not found. That's interesting. Maybe we want to send 404 for not found, but that's okay. If we want to do something that is like a user with a bad password, then we would expect to have something from the system that would tell us that, right? So we can do that. And now we can see that the response code 400, and we can, here we go, let's try that again. That's what happened with live demos. Sometimes you just see that. And now you can see that we have some other codes here. Oh, that's from orders. And let's do that again. Here we go, do the login. And now we have the login here. And here we also see that it's not found, but it's actually a different problem. Now the password is different. So I can quickly do something in my application and then see it in Mizu. Great. So I can troubleshoot now. I can see the full request. By the way, everything that you see here with those cute little green stuff, you can literally query on that, meaning I can actually go and ask for a specific authorization key and say, hey, I want to see traffic only from that authorization key. Oh, you're probably asking yourself, hey, security, what's up? I'll touch that in the Q&A. So I can decide on a protocol. I can see whatever I want. Everything that you can see here can be queried, including something cool for the SREs of us. Let's say I want to see all the HTTP requests that have a performance issue. So the response time is over 200 milliseconds. And I can click apply and just sit back, relax, and run my performance test maybe, or track my CI/CD tests to see if something broke the response time. Cool, that's great. We found it. Now we want to set something to help us catch it when it's in action. So if somebody is going to deploy something that creates a problem or break an API, how can I actually catch that? No problem. For that, I actually spawn Mizu as using the Helm chart, and that part is being monitored consistently. So I'm actually using Mizu now, not as a point and shoot tool, just something that is long living in my cluster. And for that, I can just go here and click on the traffic rules. The traffic rules allows me to define rules on the traffic, and Mizu is constantly tracking those. So exactly what we did there, I want to see all the errors that are in my application. I can do that here, decide how I want to see the notification, get them per minute, per hour, depending on the environment, and see a trend of what's happening with my application errors. So you can see that for some reason in my WebSock, the more time goes, the more errors that I'm accumulating. So I have a problem and I can just click here, go to that. Another thing that I can do is I can actually ask Mizu to show this, create a spec, and then go and make sure that all the APIs are conforming to the spec. So for that matter, we can just go and let's create a new one. Let's say we want to have I already done front end. Let's say I want to do orders, and on the spot you can see that Mizu can generate that. So I'll do fetch, and Mizu will create on the spot an open API spec based on the traffic. I didn't have to do anything with code and etc. Press save, and now I can just tell Mizu, go. What does that happen? Go back here, and I will create a new rule. And I'll say I want to conform. I want to make sure that this service conforms to spec, and that's a little bit late for me today, but we'll see. Obey. And all I need to do is just put the service name here. Make sure this is a valid JSON. Press save, and now Mizu is going to start tracking that service. And I can of course add more rules. So I can say, hey, I want to make sure OAuth is there, and I want to make sure there are no errors, and I want to make sure maybe limit that to only things that happen on the login page. So we can now not only find errors with our application, we can now set rules that allows us to basically get alerts if somebody breaks the contract, or if somebody, if we have an accumulated amount of errors or response times or whatever we want. Everything that you can do here, you can do in that screen. And last but not least, I want to show you, since we are also looking at the traffic, what if we have PII? And for PII, there are two use cases that I want to cover. One is the first that, hey, I'm trying to gonna call users API, and I get the full details of the user, including the address. And then I decide to just transfer that data into a different API, but I have not concatenated the address, for example. It's not necessary that the PII needs to go to that service, right? So if I want to be responsible and I want to make sure that I only deliver the data that I need, and it's not necessarily the developer's fault. Maybe there are some information that it's not so obvious to know that you should not send that to a different service. So what you can do, you can actually tell Mizu to look at your PII. So I've prepared something like that in advance. And you can select multiple things. One is you can create your own rules. Second, we actually teamed up with guys in Microsoft, which create a really nice library that look at text files and allows you to identify PII there. So we embedded that as well. Thanks, Microsoft. And you can build a report, which first of all shows you real-time traffic. So if we look here, this is going to be funny. All those persons we identify them as names, and at 85%, which is funny. I always like Chewbacca, and I think really to understand that Chewbacca is a person, you need a lot of AI for that. But not only, you can actually see stuff like, let's see here, from the front end, I can see location. I can see, where is that location that I had? Here, so we can see Glasgow as a location. We can see United Kingdom as a location. And that's, again, of course, this is come out of the box, but you can add your own rules. So if you need to be HIPAA compliant or something like that, you can obviously create your own rules and do that. And of course, this is, instead of just looking at the real traffic, you can also create a report, which takes some time to do that, of course. And you can maybe say, hey, after every CI cycle, that's what I want to do. I want to have a report and make sure that we have PII under control, and kind of know that you're on top of that. The second use case, which is not that obvious, but it's more tricky to know, is what happens if your users accidentally give you PII. So if at the developers we were able to control, think of, let's say you implemented a chat or some kind of a system that like support, right? And then somebody sends you a ticket, say, hey, please refund me, and here is my credit number. An honest mistake. However, now you got PII in your system without you even knowing about that. Those are the kind of things that if you look at the traffic and you can identify that, you can create an alert and then just go and delete it exactly from that point in time, and that's it. Super. So quick break. I want to see if we have any Q&A. Questions? Not yet. Okay. Feel free to use the question section to ask any question that you want. Some questions that we get usually is that, one, how to do the entire cluster, how to see the entire cluster, how can I remove items from my observed traffic? Interesting. Are we a sidecar? And what permission do we require? And what is the overhead for that? So, as I said, Mizu tap -a just gets you everything, including the kube system. So maybe you can even try and identify problems with your Kubernetes if you're not running on one of the cloud vendors and you're just implementing Kubernetes vanilla on your laptop or on-prem solution. Can you redact? So out of the box, Mizu identifies important information such as tokens, authentication, username, passwords, etc. And it removes that by default. Both on the point and shoot tool or on the long living installation, you can decide on the spot if you want to redact the data or not. As a point and shoot tool, it's obvious that you are the one that execute that. The default is that we will not show redact, and when we don't show any data, we redact it at the source, meaning everything I showed you, like for example, the open API spec that you can generate and the code snippets that we have, all that will not include that. The second thing is that if you do need that, it's just a click of a button away from you. So let's say you do need that, you can just turn it off and see that. You need to be an admin in Mizu for that. So take that into consideration. And you can also specify your own regex pattern or something that you want to do, just in case, if you implemented such a token that is on your side, you can do that. I also kind of provided the link here. So because it's open source, you can literally see everything. So this is our documentation. You can just see that there are like 2 files that define all the rules for that. Sidecar. So no, it's not a sidecar. The reason is we actually started with sidecar and it just doubled their resources. Then we use daemon sets and we use a little bit of eBPF for that. So what the permissions that we actually need. The beauty of Mizu is it's a couple of layers of that. So for example, if you don't need any TLS and then to see any encrypted data, then assuming you have kubectl deploy, you're good to go. Like if you can deploy your application, you don't need anything other than that. But if you would like to see MTLS from your Linkerd or from Istio, then we would need some Linux capabilities. This is also true if you need TLS, because then we need to literally put eBPF there. But the beauty of it is that if you are running in an environment that you cannot get those Linux capabilities for whatever reason it is, a vendor or security or etc., you can still benefit from the unencrypted data for that, or just use it for the service mesh and not for everything, and then you'll be able to do that. And what would be the overhead for such kind of a tool? Overall, very low. We're using libpickup and some eBPF. It's a good thing to remember that at first the open source is really great if you're having your development environment or maybe staging environment. You need to remember that the database, as it comes out of the box, it's a bit limited. So don't expect like 30 days of retention to slice and dice. This will require something like a little bit customized for that. But as a developer, if I just need to have exactly the ability to just see my network while I am trying to debug my problem, should be sufficient, and you have everything that you need over there. One thing that I see that I have some time to cover is code snippets. The same thing that we have done with Mizu to just see it. Where was that? Let's just reactivate that. There we go. Anyway, do it that way. So when you have Mizu, you also have a service catalog, which we showed, and you can just see all the open API specs, and we also keep examples for that, which response code that you get. Another thing that you can do is get code snippets for the services that you just observed. So we create all the, you have all the languages here. That's for the sake of that, just select curl, and you can see all the services and all the endpoints that you have. And wherever you see the number here, that means this is an example for the latest sample that we kept. This is a sample for a 406 response code that we saw. And this is a sample based on the OWASP, and it's like very general what you can do here. The beauty of it is that if I now need to create an integration to another service, I can quickly tell Mizu to just record what I'm trying to do, emulate that using some kind of a business case, or just let's say a collection or a test of that service. Grab that and can say, okay, now I want the code snippet for that. It's coming from it's calling shipping. Go to my code snippets and select go to shipping, and we'll just take it from here. And with that, I now can go take the code from here. If it's go, put it there, start to work with that. Easy way to start. So how do we start? That's the good question. First, contact us. If you want Mizu, you can get Mizu from getmizu.io. If you like to build it yourself from the repository, so GitHub, Up9Inc, and Mizu, feel free to do that. Our documentation here, and the Mizu community Slack is available for everybody. I'm Refael, so feel free to reach out to me directly, either email or just scan that. How are we on time? Great, we have some time for questions. Any questions?
Hey, Rafael. Wow, yeah, you were worried that you weren't going to be able to contain all. I mean, you blitzed through that. It was actually fantastic.
Yeah, it's yep. I'm don't know if we
No,
have any questions
there's no
here.
questions yet. If we just give it a minute to see if anyone wants to come over. If you want to post questions, folks, there's a tab. You can go to Q&A tab. You can type one out, and then we'll discuss it. I guess maybe to kick it off, like maybe one great one is kind of your salesman opportunity. There is Mizu must have some sort of competition. There must be something before it that you're trying to overcome. What is that, and what is the big one up that you have over what your competition is?
Uh, Good question. So first of all, is the flexibility that it's kind of layers. It's not just one technology that you absolutely have to have full permissions, like the Linux capability for that, and the easy to install that. So it's literally downloading a 20 or a 30 megabyte file, and you just point to the cluster, and you just start seeing the traffic. You don't need to install too much and or change your code or change your architecture. Uh, and just what we did here. It's really simple to start.
Yeah, it looked like it was a pretty straightforward to follow through. I guess so. Like to kind of boil it down, it's that simplicity and also that modularity. I guess you could say you can the separation concerns where you can actually choose how much access you give. Does that necessarily lead to more setup time initially compared to other competitors?
Um, no, it's once you have those permissions, then it will just work for you, right? If you don't have, then you won't see you will see traffic that is encrypted. The installation is exactly the same way, and sometimes it's not just you in a matter of permissions. Like, what if, like, let's say, let's take serverless or a place where you are not in control, like AWS Fargate or something like that. You cannot get access to node. You don't have those Linux capabilities. How can you still do that? Then you can run Mizu, and it will see the traffic coming for you quite easily. Especially if you have like a star topology where all your microservices are talking with a gateway. Sometimes you have the gateway and the BFF, the backend for the front end. So you can, for example, just tell Mizu, show me the streams to my gateway, and it will cover, and you'll see all the communication with the microservices.
Okay, seems pretty intuitive. I mean, I like that. It seems like you've kind of dumbed it down, not in a it's a simple way, but more it's very elegant from what I've been seeing from your demo. But it doesn't look like we've got any questions coming through, which is fine. If people want to reach out to you, I'm sure you have means by which they can contact you with their questions, and you seem like a very friendly guy, so I'm sure you're willing to field those questions as they come in.
Yeah, and now I know to talk meters, miles, and stones. So it's a
Oh
very
no, no! Before we came on, we were getting into the wackiness, right? Like our, I guess, kind of relates in ways like you're trying to make data more like accessible as well as more like understandable. We're talking about all these systems we have in different countries. Some driving in kilometers, others weighing in stones. But you know what? The way in here is awesome app. Definitely, you guys should check it out. And where can they get their hands on this?
so getmizu.io, and the beauty will it's choose your operating system, click here, and you're ready to go.
There you go. It's that simple, folks. So go give that a check out, and you should have a little bit of time. It's got a little bit of time until the next session kicks off. I think it's going to be about 15, 20 minutes until we're up with our next talk, which will be delivering apps at scale. But to round this out, big thank you, Rafael. It was really educational, and it's great to learn about this new software. Thank you very much.
Super. Thank you, and enjoy your coffee.